The overall goal of this procedure is to demonstrate a simple application of droplet microfluidic fluorescence detection using optical fibers.
This method can help answer key questions in high-throughput biological screening, such as the identification of rare phenotypes and the directed evolution of enzymes. The main advantage of this technique is that it allows for a simple and inexpensive application of fluorescence detection in droplet microfluidics.
To begin, place a pre-cleaned 3-inch diameter silicon wafer onto the vacuum chuck of a spin coater. Then, apply 1 milliliter of SU8-3050 in the center of the wafer and spin the wafer to provide a layer of photoresist that is 80 micrometers thick. Remove the coated wafer from the spin coater and place it on a hot plate preheated to 135 degrees Celsius. After 30 minutes, remove the wafer and allow it to cool back down to room temperature. Next, place the wafer onto a flat surface and align the first layer mask onto the wafer. Expose the wafer under a collimated 190 mW 365 nanometer LED for 3 minutes. After exposure, place the wafer on a 135 degrees Celsius hot plate for 1 minute, and then allow it to cool back down to room temperature. Once cool, place the wafer back onto the spin coater and affix it to the chuck. Apply an additional milliliter of SU8-3050 in the center of the wafer and spin for 20 seconds at 500 RPM, followed by 30 seconds at 5000 RPM.